We will keep on moving. Class gets recorded, and I hope you know that now live streaming has stopped. We are not live streaming the classes, but the classes are getting recorded. So, if somebody needs access to the class hereafter, you cannot directly go in the YouTube. You have to go in the app and click the link. Only link can open the video. You cannot see the video directly in the YouTube now. So, we have stopped live streaming, and now the videos of the classes can be seen only through the link which is posted in the Wisdom Academy app. So, be very careful about that. Don't think that it is already there in YouTube. It is not there in YouTube hereafter. Okay. So, if I remember in the previous class, we have learnt about refraction through the triangular glass prism, isn't it? We did that. We concluded by finding the value of refractiveness of prism mu p is equal to sin A plus del min by 2 by sin A by 2, isn't it? Up to there we solved. So, today we can proceed from there, and today we give the heading as refraction through spherical surface. Heading is refraction through spherical . Okay. Now, please pay attention. When I am saying spherical surface, what do I mean? Understand that first. I am not talking about the lenses here. Spherical surface means something like this also. For example, if you see in your 11th you studied about meniscus, you remember? Upper lower we will see in the laboratory, concave meniscus, convex meniscus, plane meniscus based upon the adhesive and cohesive forces I taught to you when I was teaching mechanical properties of fluids. That time, if I am having a meniscus like this is taken as a spherical surface. Are you getting my point? Sometimes because of surface tension, the topmost layer will have a some kind of membrane formation. That is also having a curved surface. This can be taken as spherical surface. So, first of all, you understand the meaning of spherical surface, where are you going to use it. So, spherical surface may look like this, or spherical surface may look like this. Give me a second. That if I say spherical surface, imagine something like this or something like this. So, now we are going to see, now we are going to derive a very important derivation for school examination. In your school examination, expect a derivation to come from this topic, refraction through spherical surface. I am even telling you what is the end result going to be. The final expression is going to be mu 2 by V minus mu 1 by U is equal to mu 2 minus mu 1 by R. Those who have learned ray optics in school, they may have learned this, right? How this formula has been derived. Today we are going to learn that first. Before we start taking numericals from this topic, we will take numericals also today. But before we start taking numericals from this topic, today I am going to teach you how that formula has come. So, please pay attention and learn the derivation of it. And as I told you in the previous class, that in ray optics we are having some assumptions. For example, lenses are always assumed to be thin lenses. In this case, lens is not there. One important assumption was rays are paraxial, remember? And what is the meaning of rays are paraxial? Rays are paraxial means angles are very small, isn't it? What is the benefit of angle being very small? Exactly. We can take sin theta as tan theta as theta. Whenever we want, we can change theta with tan theta. Whenever we want, I can change tan theta as sin theta as per my convenience. That is the benefit you get if you take angles as very small angles. For very small angles, theta is equal to tan theta is equal to sin theta. Always remember that, because in this numerical also, in this derivation also we are going to use it. So now what do we have? I am having a spherical surface, let this is principal axis, and here I am having an object O. My intention is to find its image. Everybody please pay attention. You can take time for writing later. Anshul, Amruta, your video is off. So if I want to make the image formation, I will take two rays. One ray I will take on the principal axis itself going straight. Second ray I can take making an angle of alpha with the principal axis. You can take any angle. The moment it hits the surface, what you will do? You will draw a normal. That should be the good habit, drawing the normal, because at normal only you can decide whether the ray will be going away or towards. Imagine outside medium refractive index is mu1, inside is mu2, and I am assuming that mu1 is less than mu2. It means light is travelling from a rarer medium to a denser medium. How it will bend, towards or away? Towards. So instead of going like this straight, it will bend towards, it will go and it will hit somewhere here. You may have a doubt now, or you may think like this also, that let it bend, but what if the bending is not sufficient, little less bending? It may go like this also, no? In that case, it is never going and intersecting there. What will happen? In that case, there will be a virtual image formed on this side. Please understand the ray diagram. If you fail to understand the ray diagram, derivation also you can mug up, numericals you will have struggle. So understand how I am doing the derivation. So there are two possibilities. One possibility is curvature, that is the bending of the ray is sharp enough to make the refracted ray go and hit where? Principal axis. In this case, what image will be formed? Real image will be formed, because one ray is coming like this, another ray is coming like this, they both are intersecting here. Here we will have the image formation. Second possibility was the bending was less and the light went like this, and we are extending behind and we are joining here. Here the image is forming, and this image is what image? Virtual image. Both possibilities are there. Here I am going to derive with an assumption that light has got sufficiently refracted and the image has formed somewhere here. Okay. Let this angle normal making, that is with this reflection, is beta, and let this angle be gamma. I am having alpha, beta and gamma, and this is the angle made by the incident ray with normal. Let this angle be angle of incident, I am taking it as theta 1, and let this angle be angle of refraction theta 2. All the angles are clear to you? I am having 5 angles here: alpha, beta, gamma, theta 1, theta 2. Alpha is this angle made by the incident ray with the principal axis. Beta is the angle made by the normal with the principal axis. Gamma is the angle made by the refracted ray with the principal axis. Theta 1 is the angle of incidence, theta 2 is the angle of refraction. This is the object distance, isn't it? By convention it will be minus, because direction of incident ray is like this and I am measuring against it, so this is a pole P, so it is negative. This is radius of curvature, positive. This is image distance, positive. Do you agree with me? Since the direction of image and direction of center of curvature are in the same direction of incident ray, we are taking both of them as positive, whereas direction of object distance is taken as negative because it is against the direction of incident ray. Is everything clear to you? When everything is clear to you, only I can start derivation part of it. I am just talking about the diagram now. If you see this diagram clearly, what I will do, I will just drop a perpendicular here. Let this point be anything, P dash I will take, and let this height be some h. It will anyhow get cancelled. So if you see this triangle, let this point be what? Okay, M. So in triangle I wrote in P first. So, P dash O M, this triangle I am taking. Okay, I am talking about this triangle. I hope you understand which triangle I am talking about. I am talking about this triangle, right? Understanding now? So, this triangle, I am interested in finding what is the okay, why POM? I can take COM. That will be more easy. If I take COM, I can write alpha plus beta theta 1, isn't it? Because it will give me exterior angle property of a triangle. Same way, in triangle CMI, I can write theta 2 plus gamma is equal to beta. This plus this is equal to this. Same logic. In a triangle, sum of interior angle is equal to exterior angle. So, from here I will get theta 1 value. Theta 1 value is alpha plus beta. And here you got theta 2 value. Theta 2 value is beta minus gamma. Is it clear to you? I have got theta 1 value, I have got theta 2 value. Now, let me find on this side what is tan alpha, what is tan beta, and what is tan gamma. What is tan alpha? What is tan alpha? H by U minus U. What is tan beta? What is tan gamma? Tan alpha, tan beta and tan gamma. Everything is clear to you? How it came H by minus U, H by R, H by V is clear? This triangle and this triangle. Okay. Now, by using Snell's law, can I write mu1 sin theta 1 is equal to mu2 sin theta 2? Can I write like this? That is what is Snell's law. Or I can write mu1 theta 1 is equal to mu2 theta 2. Can I write like this also? Just now I told paraxial rays sin theta can be taken as theta. Now, what is theta 1? Alpha plus gamma. So, I can write mu1 into alpha plus beta only, no? Beta is equal to mu2 into beta minus gamma. Can I write like this? I hope I can write. Or I can write mu1 into tan alpha plus tan beta is equal to mu2 into tan beta minus tan, right? What is tan alpha? H by minus U. What is tan beta? H by R. So, here we are going to have H by R minus H by V, isn't it? H is common, it will get cancelled. I told it is going to get cancelled anyhow. Now, I am going to have mu1 by minus mu1 by U plus mu1 by R is equal to mu2 by R minus mu2 by V. Rearrange it, you will get mu2 by V minus mu1 by U is equal to mu2 minus mu1 by. Is it clear to you? This is an important derivation which comes in school exam for 3 marks, where they will ask you to derive the diffraction through a spherical surface. If it is clear to you, then you can start copying it. If there is no doubt, please copy it fast. I will give some numericals based upon this then. Let me know when you are done. I'll change the page. Is it copied? Can I go to the next page? All of
Just a
you,
minute, sir.
make it fast, make it fast.
Sir, I have a few doubts in the ray optics chapter, sir, regarding previous topics.
What doubt you have? Tell me.
So before some,
Okay, which topic? Tell me the topic name. Can I go to the next page meanwhile?
yes, sir.
Yeah, Harvish, you are saying something?
Nothing, sir.
Okay. Shakti, will you not told me what topic you have problem?
Snell's law, sir. Snell's law.
Okay, Snell's law,
Uh,
the understanding of that or numericals based upon that?
numericals, sir. I'm not getting the numericals at all.
Okay, then we'll solve some numericals based upon that in some class. Maybe today or some other day I'll keep a class for you. We'll solve some numericals based upon that.
Okay, sir. Thank you, sir.
Yes. Copy it fast, guys. Let me know. We'll solve some questions then. Have you copied? Shall I give some question then? I have some questions from this topic. First, we'll take some very simple question. Shall we? All of you are done writing, right? So, mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Remember that u, v and r should be with conventions. If you make a mistake there, you will not get the answer. Okay. The first question goes like this. So, there is a very similar to what I drew for derivation. I am drawing a spherical surface, and then they have given the object distance as I think 20 centimeter from here, 30 basically, 30 centimeter, and they have given the outside medium is air, so its refractive index is 1, and here the refractive index is given as 1.5 glass, and they have mentioned that radius of curvature is 10 centimeter. That is all. They are asking you to find the position and nature of image. Find the position and nature of image. Make it fast. Position and nature of image. This is the question. Make it fast. Any answer? Direct formula based question here. (96 centimeter), 90 centimeter, plus or minus. So whether it is, what is the nature of image? Real and, don't say inverted, point only. Real image at 90 centimeter. Okay. What is the value of mu? What is the formula here? Mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Now tell me, what is the value of u here? U is how much? Minus 30, okay. What is the value of r here? Plus 10 centimeter, good. What is the value of mu1 here? 1. What is the value of mu2 here? Just put in the formula and get the answer. You put in the formula and get the answer, yes, answer will come V as how much? 90. Plus 90 centimeter. Since it is plus 90, you can say it may be forming on this side. So, it is really meeting to form the image, it must be a real image. Remember that. One more way of remembering is there. Always remember that if u and v have opposite signs, see, valid only for lenses and spherical surface, not for mirrors. If u and v have opposite signs, it means the image is a real image. And if u and v have same sign, then it is a virtual image. Are you getting a point? Remember this. So here u was negative, v was positive. So obviously you have a real image forming, right? Can I go to the next question? Take the question. It's a good question. Question is, a dust particle O, dust particle O is inside a sphere. Dust particle O is inside a sphere of refractive index 4/3. Of refractive index 4/3 as shown. I'll draw a diagram now. As shown. Where does it appear to the observer? Where does it appear to the observer outside the sphere? Where does it appear to observer outside the sphere? Outside the sphere. Okay, so how they have given? Leave it. They have given like this. A circle, okay, and then its radius is given as how much? Have they given the question? No, right? It is given as 15 centimeter, and refractive index is 4/3. 4/3 means it is water. It means it is a water bubble, and dust particle is 10 centimeter towards the right of the center. Is it clear to you? This yellow dot is the dust particle. That's all given. Find the answer. Outside is air, obviously. Actually, not 10 centimeter, it is 5 centimeter. Sorry. Please check your answer. This is 5 centimeter. Okay. Dust is present 5 centimeter away from center. Dust is present 5 centimeter away from the center. You have to find the position and nature of the image. Be careful in solving. Thirty by? No.
Sir,
Yes.
sir, is it virtual image, sir?
Virtual image. Virtual image. Okay, how much is the answer? Yeah, it may be virtual image also, Krishna. It may be.
-7.5 centimeters, something like that.
Minus 7.5. Let us check. Others. Any answer?
Sir, I got 6 centimeter.
You got 6 centimeter.
Yes.
Plus or minus, man?
Plus 6. Sir.
First of all, to solve this question, you need two things. One is, one case is there if the eye is seeing from this side, isn't it? I not mentioned that. Somebody can even solve like this. For this person, the object distance will become how much, you know? From here, 15 plus 5, minus 20 centimeter. Why minus? Because rays come like this in this direction. For this person, what will be u? Minus 10 centimeter. Because here it is at 10 centimeter from this point. So its rays goes like this, so minus. Is it clear to you? So we will have two answers here. One, if someone is taking the object I to be on the right hand side, somebody is taking I to be on the left hand side. So in this case, what will be the value of r? R will be same in both cases. How much? Minus 15. Here also it is minus 15. In this case, what is the value of mu 1? 4 by 3. Mu 2? 1. Here also mu 1 is how much? 4 by 3, and mu 2 is 1. When you solve with all these data, tell what is the value of V you are getting here, and with this data, what is the V you are getting here. Both can be the answers. Anybody has solved? How R is? Because ray is going in this direction, incident, and R you are measuring in this direction, so minus 15. Getting my point? Same way, if somebody is seeing from here, rays are going in this direction, and R you are measuring in this direction. So always check the sign convention based upon the direction of what? Direction of incident ray. Are you getting my point? Anybody has got the answer by these calculations? So we will have two things here. This is case 1 and this is case 2. Make it fast. Yuvashri, your mic is on and your video is off. Ulta should happen. Video should be on, mic should be off. Right. Anybody got the answer for this case 1?
Negative 10 centimeter.
Negative 10 centimeter for V. Maybe. Negative 10 means it is forming at the same place where the object is there. I think check your calculation. It is like where the object is there, same way the image is there. It is not possible, I guess. There is a mistake in this. Please check your calculation, Varshita. Shall I solve it? mu 2 by V, 1 by V minus mu 1 by U, 4 by 3 it will become plus U. Let us check. Mu 2 minus mu 1 by R. So 1 minus 4 by 3 divided by R is how much? Minus 15. So when you solve it, it will become 1 by V plus, what is this here? 4, 4 by 30 is equal to 3 minus 4 is how much? Minus 1. So minus 1 minus will become plus 1 by 45. So I am getting something like 1 by V is equal to 1 by 45 minus Am I audible now, Kirti?
Yes, sir.
Yes, sir.
Yes. So is any mistake I have done in calculation? I am getting minus 9. Are you getting the same or something else you are getting? Where is the mistake I had? I think I have done correctly only. Mu 2 by V minus mu 1 by U is equal to mu 2 minus mu 1 by R. Mu 2 is 1. So 1 by V minus mu 1 is 4 by 3. So 4 by 3 into U. Yes, mu 3. What, Ivan? Not audible again. Come again. You are getting the same minus 9.
Yes, sir.
Then I am right. Okay. Anybody else getting the same minus 9? Check your mistakes if you have done something in calculation.
Sir, I don't think so. I got minus.
I got minus 9, but I used some other value, sir. So I don't think. But I know that this is not right.
This is not right. So find the error, man. I have done in front of you only, 3 minus 4 is minus 1. Minus 1 by 45, so it will become plus. Minus 1 will become plus. This is correct. Then 1 by V is equal to, this goes, that's why 1 by 45 minus 4 by 30. LCM is 90. 45 2s are, so 2. And 33 are, so 4 3s are 12. I don't think it is having any, 2 minus 12 is 10, minus 10. So minus 10 by 90, minus 1 by 9 is 1 by V. V is minus 9. I don't think there is any error in my calculation, if I am right. Please check yours. Same way, when you put the value of mu 2 and mu 1 here and solve, you will get an answer. Are you getting a point? I will not do that now. You do it later. But I hope you have understood the problem. See, don't always expect the question to come like V is given, U is given, R is given, find the answer. It will not happen like that. Take the next question, then you will understand how the question is coming. From board examination, 3-mark question. Question is like this. There is an object present here. This is a glass sphere of refractive index 3 by 2, that is 1.5, and outside is water. So water means refractive index is how much? 4 by 3. Outside means all around water is there. What they have asked you, they have asked is, if there is eye present here, okay, and the object is kept there at a distance of 20 centimeter from this point. Here also it is water only, guys, all around water. They are asking you to find the position and nature of the image. Question is clear? That is, they have given, I think, they have given the value as 10 centimeter. R is given as 10 centimeter. Yes.
First one will be act as and second image.
Exactly, that only will happen here. Double refraction will happen here. Think and solve. First, this interface will refract, it will have an image, that will be acting as an object for the second interface. Once again, you will solve, you will get final image, correct. So, it's a good 3-mark question that has come in the board exam already in the past. Try to solve this, I will help you if you are not able to solve it. Give a try, I will help you if you are not able to solve. I have given you hint for the first interface. What is the value of mu1? 4 by 3. What is mu2? 3 by 2. What is u? Plus or minus? Minus 20. What is r? Plus 10. For this data you will get v. However it comes, plus or minus, I don't know. After that, think properly, because from that interface you should find the value of u. And then what will be mu1? What is mu2? Then you will find the value of v, get the answer. R will be plus or minus in second interface? Negative. Because ray is going in that direction and you are measuring R in this direction. R will be negative for the second interface. Be very careful. Solve this and get the answer. I am there to help you if you are unable to get it. Got the answer? Final answer you are saying?
20 centimeter.
That is final answer or half the answer?
Final answer.
Let me check. Solving. Okay. I'll solve it, guys. Pay attention. Those who are not solved, please see. Those who have solved, please check your answer. So as I said, step 1 is we'll take this as the interface, isn't it? So we will take the value of mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. What is mu2 here? 3 by 2. So 3 by 2 v you want to find minus mu1 is 4 by 3. So 4 by 3 u is how much? Minus 20 is equal to mu2 minus mu1 3 by 2 minus 4 by 3 by r is how much? 10. When you solve this, 3 by 2v minus will become plus 1 by 15 is equal to LCM is 6, so it will become 60 below, and this will become 9 minus 8, 1 by 60, isn't it? So 3 by 2v is equal to 1 by 60 minus 1 by 15, LCM as 60, 1 minus 4. So minus 3 by 60, it will become 20. So 3 by 2v is equal to minus 1 by 20. 2 will make it 10 times. So I am getting v value as minus 30 centimeter. Are you getting the same thing? V as minus 30. It is the first V. It means the image will be 10 centimeter behind this, isn't it? 30 from here. Now what will be the, in the second interface, what will be U? 10 plus 10, 20 plus 30, 50. So U will become minus 50, isn't it? I am talking about second interface. What is mu 1? 3 by 2. What is mu 2? 4 by 3. What is R? Minus 10 centimeter. With this data, if you solve, find the value of V. They were actually told 20 you are getting. Did you get 30 first of all?
Sir,
Yes,
why
Kirti?
is U minus 50, sir?
Because Kirti, we are seeing from this interface now, right Kirti?
Oh, okay, sir.
So from here if you add 10 plus 10, 20 plus 30, 50.
Okay.
Now this image by the first surface will be treated as the object for the second surface. So for this we need to find the image formation once again. So check and tell me what is the answer you are getting. Everybody try, please, don't give up. All of you, please give a try. Make it fast.
You have changed the mu1 and mu2, right?
Yes.
Why?
Why? Because in this case, light was coming, hitting here, entering in this medium, right? After that, light is hitting this medium and entering this medium. So in the first interface, this was the first medium, this is the second medium. In this interface, this is the first medium and this is the second medium. Are you getting a point, Amrita?
Yes, sir.
That's why I am changing mu1, mu2. Understand the logic. Any answers? Still solving. Very slow in calculations. Minus 45. Minus 45 means it is somewhere here finally. 5 centimeter before it. That's what you are getting. If your answer is right, then the correct position of the image is 5 centimeter from its original position towards its left. If your answer is right. I am not knowing, others let them solve. Whether you are also getting minus 45 centimeter with the calculation?
Sir,
Huh?
I'm getting 100, sir.
100.
Sir, me too. 100.
It's negative 100%.
Negative 100. It means your answer is wrong. Shweta Shinde. Check. So the correct answer up to now, because of majority, it goes to minus 100. Okay. So answer is minus 100. What about you? Anybody getting in this room 100?
Minus 100.
Huh?
Minus.
Minus 100. Yeah, that's what. So minus 100 you got. Minus 100 means it has formed from its original position how much away? 60 centimeter away, because 50 here and 40 more away. From here 100, right? From here 100 means this 50 plus 50, isn't it? So from the original position 60 away. That's where the image is forming. If V is minus 100 means from here you have to go how much distance away? Minus 100 and plot the image diagram, image of that. Are you getting what has happened? If you have doubt in this question, ask me. If it is clear, we will go to the next concept. This is the maximum level of question that can come from this topic. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R based questions can be complicated till here only in the school level. If you are okay with this, I will go to lens now. Shall I go to lenses? All of you are done? Any problem is there anywhere? No? Assume like that? Okay. So next topic in this chapter is lenses. Give the heading as lenses. Okay. Lens is not new for you. You have learned about lenses in your 10th standard also. So lenses basically how they are made? Any idea? Solids? Solid sphere. From solid sphere what we do? Loudly? I am unable to hear you clearly, Pratap. It is not audible to me. Yeah, please. Mic little away from your mouth. Speak again. I cannot understand still. You can, you are, okay, fine. I read your message. You are saying acrylic material. I am not asking the material, Pratap. I am asking how it is made, the what do you say, the manufacturing, how it is done. Acrylic material, not always. We are making by glass also lenses, isn't it? Combination of two mirrors. No. Two curved solid glasses. So you have a solid spherical glass, two solid spherical glass. When they are clubbed together, joined together, then it forms a lens. Basically, there are many types of lens. Okay, if I ask you define lens, how will you define lens? By the same way like how I told you now. You cannot define, right? The correct way of definition is, it is comprising of two transparent mediums. One of it must be spherical. Remember that. Right definition. Lens is an optical device. An optical device which is made by the combination of two surfaces, one of them must be spherical. Combination of two surfaces, one out of which must be spherical. One out of which must be spherical. What do you mean by that? I mean that if you have something like this, what is this called as? Biconvex. You are in higher class now. Why biconvex? Because both sides you have convex surface. You may have something like this also. What is this? Huh? Plano convex. One side plane, one side convex. Same way, what will be this? It's biconcave because both side is concave. And what about this? Let me draw here. Yes, it is plano concave. What about this? Concavo? Why not convex or concave?
Sir, first concave coming.
Here first plane is coming, huh? I will see from left, then here also. You cannot say like that. See, it can be concavo convex or convexo concave. Both possibilities there. Based upon what is its net nature. Understand one thing. Biconvex means it will have a converging nature. Am I right? It will have a converging nature. Biconcave means it will have what nature? Diverging nature. You know, if it is plano convex, it will have a net converging nature. If it is plano concave, it will have a net diverging. It will be less diverging than biconcave. It will still be diverging only. Same way, if it is concavo convex, it has a net converging nature. If it is convexo concave, it will have a net diverging nature. So, purely based upon what is its nature, and we cannot comment on its nature by seeing the diagram. By solving, you have to find and check whether it is a net converging or net diverging. If the lens is net converging, we can put it as convex at the last. For example, concavo convex. If net nature is diverging, we can put convexo concave. Are you getting a point? These are different types of lens. So, as per the definition, you cannot have two plane surface called as lens. It will be rectangular glass slab. One can be plane, but one must be spherical. Both can be spherical, possible, but one should be definitely spherical. I hope you are getting my point. Okay. Now, if you have a lens, yeah, tell me, Yuvashri.
Repeat that definition again for lens.
I said lens is a transparent optical device which is made by the combination of two surfaces. One of them must be spherical. I will repeat, Yuvashri. I said I not saw, I just told. What I said?
Lens is an optical device.
It is an optical device
Combination of two surfaces.
made by combination of two surfaces.
One of
one out of which must be spherical. One out of which must be spherical. You actually copied? Okay, I'll proceed further. Pay attention now. See guys, if you have a convex lens, okay, and if you have rays coming from far, what will happen? They will converge. At what point? True. What this focus is called as? It's a real focus, because rays are really converging to form the focus. Same way, if I am having a concave lens and the rays are coming from infinite parallel to principal axis, what will happen? They will get diverged. I hope you have learned this in your small class. And if you extend in the back direction, it will also meet at a focus only. What focus will be that? Virtual focus. So focus of concave lens is virtual. Focus of convex lens is real. Why understood? Because rays are really intersecting. Rays are meet to intersect here. Okay, one more thing I want to ask you. If rays are coming parallel to principal axis, conveniently we say it meets at focus. What if I am having a lens and rays are coming from far only, but not parallel to principal axis? What will happen? Will it still meet at focus? Where will it meet? Anywhere? Or we have a fixed point? No, obviously, but that there is a click here. There is a point here. It always meets at a point. That point will lie on the focal plane. Are you getting my point? Now, what is focal plane? You know, it is a plane drawn perpendicular to principal axis passing through focus. So, if rays are coming from infinite, after converging, it will pass through focus. If they are parallel to principal axis, it will pass through some other point which must lie on a focal plane if it is not parallel to principal axis. Is it clear to you? So, what is focal plane? Focal plane is a plane which is perpendicular to focus and passing through the focus, obviously. I hope you are getting my point, right? Okay. Now, most of you would remember that if a ray is passing through optical center, it is undeviated, right? Know this? Why? Any other point if the ray is touching, it is getting refracted, bent. But why ray is passing through center of curvature, it is not bending? Along normal. Oh ho. So you are thinking that normal is this center of curvature is normal, not mirror here. Then what? One more thing I will tell you. This is true, these things are true only for thin lenses. As I told you, this chapter is purely on the assumption that we are learning about what lenses. If it is thick lens, no, it will not have single focus, it will have multiple focus. Because if it is thick lens, it will form here also, it may join here also, it may join here also. Only for thin lens, the converging happens at a single point. Okay, coming back. So here, if you see the center part of lens, whether it is a convex lens or a concave lens, whatever you see, central part, does it look like a rectangular glass slab? In rectangular glass slab, if the ray enters like this, it gets refracted, once again gets refracted, and these two lines are always parallel. And there is a, see, if you remember like this, there is something called as lateral displacement, am I right? It is not in the portion now, it is called as shift. Shift formula is T into 1 minus 1 by mu. This is the formula. Shift is equal to T into 1 minus 1 by mu, where T is the thickness of the glass slab. So, more thickness, more shift, less thickness, less shift. We assume our lens to be a thin lens. Thin lens means less thickness means Less shift, very less shift. That's why we assume it to be a straight line. Are you getting what I am trying to say? You may ask, why not other parts? Because other parts, if you take this thing, it will not behave like a rectangle glass slab itself, isn't it? It will be like a trapezium. It behaves like a rectangular glass slab only in the central part of the lens in both the cases. That's why any ray passing through its optical center goes undeviated, because shift is least there, and if shift is least there, then it can be assumed to be almost like a straight line. That is the reason for light being undeviated when passing through optical center. Coming back. Now let us learn about lens maker's formula. Again, a very important derivation. Today already one derivation we have made. Somebody knocked? One derivation we have made. The derivation is refraction through the spherical surface. Like that, this also is very important, lens maker's formula. It is not lens formula. 1 by V minus 1 by U is equal to 1 by F. That is lens formula. It is not that. It is the formula which is used by the makers of the lens manufacturing plants. Like you get some eye defect, you go to ophthalmologist, the doctor, you show the doctor, he checks your eye power and he prescribes a lens. He does not make the lens and give you. He gives a prescription. Then you go to a spectacle shop, lens makers or lens cart, whatever, and then you give the prescription to them, then they make it, right? So on what logic they are making, that one you are going to learn now. That's why the name is lens maker's formula. Are you getting a point? Lens, I will give the definition to you, I will give the final result to you beginning itself, we will get that by derivation. We are going to get 1 by F is equal to mu L by mu M minus 1 into 1 by R1 minus 1 by R2. This is the final expression which we are going to get of the lens maker's formula. How it comes, we will derive it now. Okay? So mu L is the refractive index of lens, mu M is refractive index of medium, R1, R2 are the radius of curvature of both the sides. Always remember that in lenses we have two sides, isn't it? So if you see here, this side will have its own radius, this side will have its own radius. It may be same if it is a biconvex lens, or if these two sides are having different focal length, it may be different also. Don't think it will be always same. So generally it will be same. Okay, anyhow. So what I am doing now, I am taking a lens. See, I am assuming thin lens only, but to make you see clearly, I am drawing a thick one. Don't draw in the examination like this, and don't think thick lens. I am drawing big for you to see from where you are sitting, for clarity only. Okay. So you should understand all the, the ray diagrams. So if there is an object here, the ray, first ray I am making it to go through principal axis directly straight. Second ray I am making to come and hit here first. If it hits, what will do? You will draw a normal first, isn't it? And how do you draw a normal? You will join it with the R1, isn't it? Okay, that is C1 basically, and its distance is only called as R1. Now light is entering from a rarer medium to a denser medium. How it will bend? Away or towards? Towards normal. So it will go and bend like this. Will it stop there? No. Once again I am getting a normal, and normal will be drawn. This will be C2, isn't it? And now it has to further go. But before I tell you about that, please pay attention. If my eye would have been in this, like suppose this second interface would have not been there, then here itself the image would have formed. Are you getting? If the second interface would have not been there, then here itself the image would have formed. I am writing it as I1. But since there is a second interface, this image will not form here, and this image will be treated as object for the second interface. I will repeat this for you. Object, and this is the virtual image. Virtual image it will not form. It would have formed if this second medium would have not been there, but it's not like that, it's there. So now what will happen? it will once again bend, it will go away from normal, it will go and it will hit somewhere like this, isn't it? So, this is the final position I2 I am writing. Now, what will be this? If you see carefully, this is the object position, isn't it? This is the image position for the first image, or I write it as V dash, and then this is the image position for the final image V. Are you understanding what is happening? I will repeat this. When the object was kept here, one thing. No, I have made a mistake here. Why? This is not I1 now. This is normal only. Sorry. This is normal. It is C1. This would have been. Yes. This will be I1. So this will be V dash. Yes. So I'll repeat now. When the object was kept here, then the first refraction took place. If this second interface would have not been there, then this ray would have gone and hit somewhere like that, image would have formed there. But since I have the second interface, the ray once again bends and form the image somewhere here. So this is the object, this is the image formed by the first interface, which will be taken as the virtual object for the second interface, and this will be the final image formed by the whole lens. Now what I am going to tell you now itself. First I am going to apply the refraction through spherical surface formula for the first interface, and then I am going to apply for the second interface, and then I will add them, I will get the answer. It is very simple. So I will do that. So first you will draw a diagram first. Copy it, draw a diagram. This is the normal line.
Sir, you said for lenses we don't draw normals.
See, normal means I am drawing normal for not lenses. I am drawing normal for the surface. Are you getting my point?
Okay, sir.
Have you drawn? Make it fast. I will further solve. We'll check there. Show me. Because my calculation says that answer cannot be what the keys, what are options is there. Okay, show me. Okay, or else one more thing. Can I proceed? Now please pay attention. For the first interface, when I say first interface, what I mean? I mean this. Okay. What we are going to use? The mother formula. Mother formula is our mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. In this case, what is mu2? Light is going from where? From medium to lens, isn't it? So mu2 will become equal to mu L. Am I right? What is v? V is v dash for the first interface. I said you first interface, object distance, image distance. I hope you are getting my point. So mu2 by v dash minus mu m by u is equal to mu L by mu m by r1. Can I write like this? Is it clear to you what I have done? I have just used the refraction through a spherical surface formula and I have put the values here. Same way, tell me for second interface, for the second interface, it will become mu m by v minus mu L by u, we will write v dash, no? I said you for second interface, this is the final image and this will be the object, is equal to mu L, sorry, mu m minus mu L by r. Do you agree with me? Equation 2. Now what I will do, I will add both the equation. First you copy this first, I will go to the next page. I hope you are able to hear me now.
Yes, sir.
Yes, so if I am adding 1 and 2, if I add 1 and 2, then you see mu L by v dash and mu L by v dash will get cancelled. I am going to get mu m by v minus mu m by u is equal to mu L minus mu m by r1 plus mu m minus mu L by R2. Do you agree? Then if I take mu m common, then I am going to have 1 by V minus 1 by U is equal to, here I am going to have, if I take mu L minus mu m as common, I will have 1 by R1 minus 1 by R2. Can I write like this? Because here it is mu m minus mu m, so I am taking minus outside. Okay. So what I got? I got mu m mu m into 1 by V minus 1 by U is equal to mu L minus mu m into 1 by R1 minus 1 by R2. Now don't say I'll write 1 by F here. We have not derived until now mu 1 by F is equal to 1 by V minus 1 by U. But what we can do, see here, we can write if U is equal to infinite, V is equal to F. When object is at infinite, image forms where? At focus. So I am going to put that mu m will become equal to mu m into 1 by V is how much? F minus 1 by U is how much? Infinite is equal to mu L minus mu m into 1 by R1 minus 1 by R2. Now that goes that side, you get 1 by F is equal to mu L by mu m minus 1 into 1 by R1 minus 1 by R2. This formula is called as lens maker's formula. Sometimes, most times, we assume the medium outside is air. For air I am writing. Then the formula becomes 1 by F is equal to mu minus 1 into 1 by R1 minus 1 by R2. Don't think I have taught different formula than the how school has taught. In some schools they will not tell this itself, directly they will tell mu minus 1. If it is directly mu minus 1, it means they are assuming medium is always air. But you may get a numerical where they may have a different medium outside, water is there, something else is there, then that formula will fail. You will confuse. I should take mu as water's refractive index or glass refractive index. That is why this is the main formula. From this formula, you can get this, assuming outside medium is air. Is it clear to you? This is lens maker's formula, and if you solve some questions based upon it, then only you will get more clarity about it. First you copy the derivation. Yes, you are writing from here, no? Copy fast. Have you copied?
Yes, sir.
Yeah, please. Let me know if you are done. Done, everybody? Shall I take a question then? Always remember that we are assuming thin lenses, okay? Never forget that. So, question is, one question I am giving. If a biconvex lens of in bracket you can write R1 is equal to R2 is equal to 10 centimeter, biconvex lens of refractive index 3/2 is kept in air, refractive index 3/2 is kept in air, what is its focal length? Is kept in air, what is its focal length? How much? Maybe. Be careful. Infinite. You are taking the formula and solving, right, Shweta? The formula is 1 by f is equal to mu minus 1 into 1 by R1 minus 1 by R2. So, you are taking 1 by f is equal to, what is mu given? 3/2, 1.5 minus 1. Because 1 by 10 minus 1 by 10 will become 0, isn't it? R1 will be positive, R2 will be negative. This is only R1, no? And this is only R2, no? So, R2 will become negative, R1 will become positive. Are you getting a point? That is a twist here. So, it will be minus 10 here. I hope you get my point. No, yaar, you will get f as negative. That will be a blunder. Convex lens cannot have negative focal length, isn't it? So, 1 by f will become equal to 0.5 into 1 by 10 plus 1 by 10 is 2 by 10, which is 1 by 5. So, 0.1 1 by f. So, f will become 10 centimeter. If it is coming negative 10, Yogit, it is wrong because focal. How here? If it is minus here, minus 1 by 10, minus 1 by 10, minus 2 by 10, how it will be positive then? Pratap, actually your audibility is very poor today. You can put a message in WhatsApp. I am not able to hear you. If you are asking something, you can type a message in chat. Is it clear to you? How 10 came? Good. So 1 by f is 0.1. F will become 1 by 0.1. 1 by f is 0.1. So, f will be 1 by 0.1. What is that? Huh? 1 by 10 minus of minus 1 by 10. So, it will become 1 by 10 plus 1 by 10, which will be 2 by 10. Okay? And then this becomes 1, this becomes 10. That's how 10 came. Got it? Any doubt in this? If anything is there, please ask me. What Pratap has sent, I have to go and check in the system once again. Okay, fine. You just said that you have got the answer. Okay. Shall I give the next? What happened?
Sir, he's asking that we have done lens maker's formula. With that, we can get lens formula.
Yes, we can get. From lens maker's formula itself, you can say lens formula derivation. See how? See here. You got this step, no? This step and this step, if you solve, equate these two, then what will happen? Here 1 by f is equal to this thing. Here this take that side. So right hand side is same for both, else it will be same for both. See, from here if I take mu m this side, I will get 1 by v minus 1 by u is equal to mu l by mu m minus 1 into 1 by r1 minus 1 by r2, right, Mr. Yashwant? Now see left hand side, here and here same, here it is 1 by v minus 1 by u, here it is 1 by f. So from 1 and 2 equation I can write 1 by v minus 1 by u is equal to 1 by f. I can do like that also, okay, permitted, fine. If this question is clear, take another question before we wind off the class. One more question please. Question is, for a plano-convex lens, if r is 20 centimeter, if r means radius of curvature is 20 centimeter and refractive index is 1.5 and refractive index is 1.5. Understood this? Then you can have a good night. We will meet again in the next class. Attendance I will take. I remember your faces.